Good morning, students. Welcome back to Mathematics 9 Valenzuela Live Streaming Class. It's nice to see you again. I hope you and your family are in good condition, safe from any illness brought by the pandemic. Are you ready to learn? Great! Make sure you have your self-learning module, pen, notebook, and scientific calculator. If you don't have a scientific calculator, there are apps available in the Play Store that you can download for free. Our today's lesson is about angle of elevation. At the end of this session, you will be able to illustrate and solve angles of elevation. Before we proceed to the lesson, let's have an activity as a review of your previous lesson. You will identify the trigonometric function asked of the following special angles. You may key in your answer in the chat box. 5 seconds to answer for each item. Ready? Let's start. What is the value of sine 45 degree? Hair emoji if it is square root of 2 over 2. In love emoji if it is square root of 3 over 2. 5 seconds, go. Time's up. If you answer hair emoji, then you are correct. Next question. What is the value of cosine 30 degree? Hair emoji if it is 2 square root of 3 over 3. And in love emoji if it is square root of 3 over 2. 5 seconds, go. Time's up. The answer is in love emoji. Next question. What is the value of tangent 45 degree? Hair emoji for 1/2 and in love emoji for 1. 5 seconds, go. Time's up. The correct answer is in love emoji. Next question. What is the value of cosecant 60 degree? Care emoji for 2 square root of 3 over 3 and in love emoji for square root of 3. 5 seconds, go. The answer is hair emoji. Next question. What is the value of secant 60 degree? Hair emoji for 2 and in love emoji for 1/2. 5 seconds, go. Time's up. The answer is hair emoji. Last question. What is the value of cotangent 30 degree? Hair emoji for 1 and in love emoji for square root of 3. 5 seconds, go. The answer is in love emoji. Did you get it all correctly? Great. Without the use of the calculator, we can find the value of the trigonometric function of a special angle. What if I ask you to find the value of 65 degrees? What do you think is the answer? Some of you might wondering how to find the value of the trigonometric function of an angle which is not special. In able to find the value of sine 65 degree, we will use the scientific calculator. In your scientific calculator, look for the sine button and click. After, press 6 and 5. Then, equal sign. And that is the value of sine 65 degrees. But it is too long. We can round off the value according to what place value we want to. Example, let us find the value of sine 65 degrees to the nearest hundredths. Look for the hundredths place. Can you identify the number in hundredths place? Very good. The number in the hundredths place is 0. Now, look at the number on the right of 0. Since 6 is greater than 5, therefore, we will round up or add 1 to 0. Therefore, the value of sine 65 degree is equal to 0.91 or 91 hundredths. Another example, what is the value of sine 65 degree to the nearest 10,000? The number in the 10,000th place is 3. Now, look at the number on the right side of 3. Since 0 is less than 5, therefore, we will round down or we will not add 1. We simply copy the number. Therefore, the value of sine 65 degree to the nearest 10,000 is 0.9063 or 9,063 10,000. Are you ready now for another activity? Great! Using your scientific calculator, find the trigonometric value of each angle. I'll give you 5 seconds to answer. You can key in your answer in the chat box. Number 1. What is cosine 70 degree? Round off your answer to the nearest hundredths. 5 seconds. Go. Time's up. The answer is cosine 70 degree is equal to 0.34 or 34 hundredths. Number 2. What is the value of tangent 84? Round off your answer to the nearest tens. Ready? Go. Time's up. The answer is tangent 84 degree is equal to 9.5 or 9 and 5 tenths. Next number. What is the value of sine 72 degree to the nearest thousands? 5 seconds. Go. The answer is sine 72 degree is equal to 0.951 or 0 and 951,000. Next, number 4. What is cosine 54 degree times 15? Round off your answer to the nearest 10,000. 5 seconds. Go. Time's up. The answer is 8.8268 or 8 and 8,268 10,000. Last number. What is the value of tangent 82 degree divided by 11? Round off your answer to the nearest hundredths. 5 seconds. Go. Time's up. The answer is 0.65 or 65 hundredths. How many correct answers did you get? Great! You are now ready to learn the angle of elevation. The angle of elevation is an angle that is formed between the horizontal line and the line of sight. If the line of sight is upward from the horizontal line, then the angle formed is an angle of elevation. Horizontal line is a straight line on the coordinate flat surface where all points on the line have the same y coordinate. While line of sight is the line which is drawn from the eyes of the observer to the point being viewed on the object. Remember that the line of sight of an angle of elevation is always upward. Let us try to identify the following pictures if it is shown an angle of elevation. First picture. Is it an example of angle of elevation? Yes, it is. Very good. Can you identify the horizontal line, line of sight, and the angle formed? You can type your answer in the chat box. Segment AC is the horizontal line, and segment AB is our line of sight. The angle formed is angle X. Next picture. Is it an example of angle of elevation? Very good. It is not an example of angle of elevation. Why? Because from the horizontal line, the line of sight goes down. How about this picture? Do you think it shows an angle of elevation? Yes, you are correct. It is an example of an angle of elevation. Segment JY is the horizontal line and line segment JO is the line of sight. And angle M is the angle formed. Next picture. Is it an example of angle of elevation? Great! It is not an example. As you can see, from the horizontal line, the line of sight goes down. Since you can now illustrate the angle of elevation, let's try to solve some problems that involves angle of elevation. We have steps to follow to solve angle of elevation problem. First, draw or sketch the diagram. Second, identify the known and unknown values. Third, form an equation. And then lastly, solve. Let's try example number 1. Brian's kite is flying above a field at the end of 64 meters of string. If the angle of elevation to the kite measures 60 degrees, how high is the kite above Brian's head? First, let us draw or sketch the diagram. We need a boy and a kite. Let's draw the horizontal line, then the line of sight. Let's draw a line here to create a right triangle. Draw the symbol for triangle. Next step, identify the known and unknown values. Brian's kite is flying above a field at the end of 64 meters of string. 60 degree is the angle of elevation. How high is the kite above Brian's head? Let X be the missing part. Number 3, form an equation. Analyze the right triangle. Given the 60-degree angle, X is the opposite side and 64 meters is the hypotenuse. We can use the sine function to solve for the missing side. Sine theta is equal to opposite over hypotenuse. We can say that sine 60 degree is equal to x over 64. Let us now solve. Multiply both sides by the LCD, which is 64. We have 64 times sine 60 degree is equal to quantity x over 64 times 64. Simplify, we have 64 times sine 60 degree is equal to x. Substitute the value of sine 60 degree and we have 64 times the quantity of square root of 3 over 2 is equal to x. Multiply 64 and square root of 3 over 2. I will use the elimination method and we have 32 square root of 3 is equal to x. By symmetric property, we have now x is equal to 32 square root of 3 or 55.43 if you will solve it using your calculator. Therefore, 32 square root of 3 meters or 55.43 meters, the height of the kite above Brian's head. Example number 2. A nursery plants a new tree and attaches a guide wire to help support the tree while its root take hold. An 8-foot wire is attached to the tree and to a stake in the ground. From the stake in the ground, the angle of elevation of the connection with the tree is 45 degrees. Find the height of the connection point on the tree. In example number 2, the diagram is already given and the known and unknown values are also stated. So, from the diagram, we can now form our equation. The missing side represented by x is the opposite side of the 45-degree angle and 8 feet is the hypotenuse. We can use the sine function. So we have sine theta is equal to opposite over hypotenuse. By substitution, we have sine 45 degree is equal to x over 8. Multiply both sides by the LCD 8, we have 8 times sine 45 degree is equal to quantity x over 8 times 8. Simplify, we have 8 times sine 45 degree is equal to x. Substitute the value of sine 45 degree. We have 8 times the quantity square root of 2 over 2 is equal to x. Simplify, we have 4 square root of 2 is equal to x. By symmetric property, we have x is equal to 4 square root of 2 or 5.66 in calculator. Therefore, 4 square root of 2 feet or 5.66 feet, the height of the connection point on the tree. Let's try example number 3. From a point on the ground 12 feet from the base of a flagpole, the angle of elevation of the top of the pole measures 53 degrees. How tall is the flagpole? Round off your answer to the nearest hundred. Let us form an equation since the diagram and the known and unknown values are already given. In the diagram, the missing side represented by x is the opposite side of the 53 degree angle and 12 feet is the adjacent side. We can use tangent function to solve this problem. So we have tangent theta is equal to opposite over adjacent. By substitution, we have tangent 53 degree is equal to x over 12. Multiply both sides by the LCD 12, we have 12 times tangent 53 degrees is equal to x over 12 times 12. Simplify, we have 12 times tangent 53 degrees is equal to x. Since 53 degree is not a special angle, we will use the scientific calculator in order to solve the missing part. And we have 15.92 is equal to x. By symmetric property of equality, we have x is equal to 15.92. Therefore, 15.92 feet is the height of the flagpole. Example number 4. When the sun is 20 degrees above the horizon, how long is the shadow cast by a building 150 feet high? Round off your answer to the nearest 10. Based on the given in the diagram, the function to be used is tangent. So we have tangent theta is equal to opposite over adjacent. By substitution, we have tangent 20 degrees is equal to 150 over x. Multiply both sides by the LCD x and we have x times tangent 20 degrees is equal to quantity 150 over x times x. Simplify, we have x times tangent 20 degrees is equal to 150. Divide both sides by tangent 20 degrees and we have X is equal to 150 over tangent 20 degrees. Simplify using the scientific calculator and round off your answer to the nearest tens. And we have X is equal to 412.1. Therefore, 412.1 feet long the shadow of the building. Next example. A 14-foot ladder is used to scale a 13-foot wall. What angle of elevation to the nearest degree must the ladder be situated in order to reach the top of the wall? In problem number 5, the angle of elevation is missing. Let us identify what function will be used in order to solve the problem. Based on the figure, 13 feet is the opposite side of the angle theta, and 14 feet is the hypotenuse. We can use sine function to solve this problem. So we have sine theta is equal to opposite over hypotenuse. So by substitution, we have sine theta is equal to 13 over 14. To be able to get the value of the sine theta, we will use again the scientific calculator. Press the shift button and then sine button. And press 13 divided by 14 like this. This symbol is read as arc sine. Arc sine is the inverse function of sine. The value of arc sine 13 divided by 14 is look like this. Since we need to get the angle of elevation to the nearest degree, we will round off the value. We get the nearest whole number. And since 2 is the number after 8 and it is less than 5, therefore, we will round down. Therefore, the answer now is theta is equal to 68 degrees. 68 degrees must be the angle in order to reach the top of the wall. Example number 6. You see a huge tree that is 50 feet in height and it casts a shadow of length 60 feet. You are standing at the tip of the shadow. What is the angle of elevation to the nearest degree from the end of the shadow to the top of the tree? Analyze the given figure. What is the relationship of angle theta to 50 feet measure? And how about 60 feet measure? Very good. 50 feet is the measure of the opposite side of angle theta. And 60 feet is the measure of the adjacent side of angle theta. Since opposite and adjacent sides are involved, we can use the tangent function. So, tangent theta is equal to opposite over adjacent. By substitution, we have tangent theta is equal to 50 over 60. Same in problem number 5, we will use the inverse function to solve the angle. And of course, with the help of the scientific calculator. So again, press shift and then tangent. And then 50 divided by 60. So we have arc tan 50 divided by press equal sign. We have this value. And again, since We will round off to the nearest degree. Look now the digit next to 9. And that is 8. And since 8 is greater than 5, we will round up. We will add 1 to 9. Therefore, the measure of the theta is theta is equal to 40 degrees. 40 degrees is the angle formed from the end of the shadow to the top of the tree. I hope you understand our lesson. To sum up our lesson today, we have learned that the angle of elevation is an angle that is formed between the horizontal line and the line of sight. If the line of sight is upward the horizontal line, then the angle formed is an angle of elevation. To solve angle of elevation problem, follow these steps. 1. Draw or sketch the diagram. 2. Identify the known and unknown values. 3. Form an equation. And 4. Solve. In the problem, if the angle of elevation is missing, we use the inverse function to solve the angle. You can now ask questions. We have a question. If the line of sight is upward from the horizontal line, the angle formed is angle of elevation. What if the line of sight is downward from the horizontal line? What angle is formed? Nice question. This will be answered next live session because the lesson next week is related to this question. Another question raised. Do all calculators have the same functions? Actually, their function depends on what model or brand of calculator is used. If I was not able to answer some of your queries, you can ask your math teacher during your follow-up discussion. For your home learning task, try this 1 to 5 and keep trying 1 to 5. Thank you for listening. Keep safe, everyone, and see you in our next session.